we're going to put polarity in a little bit of context, thinking about a boat and people on a boat. If you look at the top picture with the people on that boat, notice that they're evenly balanced. And even though I have the people drawn small compared to the boat, just imagine that it's like a really small boat. And so where the people are placed on the boat actually does matter. So let's say that they see a whale or a dolphin on one side of the boat, and everyone comes over to this side of the boat. And say it stays there for a long time, so everyone wants to stay there, and they want to keep watching it. The boat, in theory, will start to do that. I'm not saying that it's going to sink or anything, but, it's maybe not in the best position now compared to where it was. So now let's take those same people and that same boat, and instead of them being people, let's pretend that they're charges. So we'll take a boat, and the boat is going to be our molecule. And say we have negative charges, and we have a negative charge here, a negative charge here, and a negative charge here, and they're evenly spread out on the boat. Does that mean that this side of the boat or this side of the boat is any more attracted to something? Probably not. But if you take that same boat and you put all of the negative charges all bundled up over on one side, and in the process, you leave this side kind of blank, it ends up making this side positive, what will happen is that boat or molecule with those negative charges will tip in the direction where those negative charges are near another positive charge. So if there's a positive charge over here, it's going to tip and be drawn to that positive charge. Whereas like over here, this side is no more likely to be drawn to the positive charge than this side. Polarity is this last picture right here. And when molecules line up with a little bit of structure to them, like let's say we have a series of boats, and they kind of line up, that action gives structure to things, and it affects multiple properties that we try to predict about an element or a molecule. If you look at a molecule, if you look at something just alone, that's not really what we're talking about. We're talking about a cumulative effect. So you might say, oh, well, just one little boat, it's probably not going to make a bit of a difference. But if you're talking about 6.022 times 10 to the 23rd of these boats all lined up in the structure, making it like a constant structure, you're going to have something that's very different overall because there are parts of it that are going to be attracted to other parts of it. That is polarity. It affects when we predict a melting point or a boiling point. Polarity will throw our predictions way off. If we try to predict tension without considering polarity, if we try to surface tension, if we try to predict viscosity, solubility, just all of these things are strongly affected by polarity. So in future chemistry courses, of course, polarity matters.